So this is a review day that neither one of these things is actually addressed in our SOLs. There is an SOL that deals with solving equations, but it actually is dealing with the kind of equations we're going to encounter as the functions that we study get more complicated. This is more of a review of solving equations that you should have had in Algebra 1. I'd be interested to know how much solving of equations you actually got in Algebra 1. We usually find not enough. But we're going to solve equations, just some basic solving equations, and we're going to solve what's called a literal equation. And a literal equation means an equation that has more than one variable. How do you solve an equation like, is anybody in chemistry or taking chemistry, right? In chemistry, you're going to come up with something like this. You're going to come up with something like this. PV equals nRT. Right? That's called the ideal gas law. And these are the variables that are in there. They're not all variables. P is pressure, V is volume, N is the amount of the gas, whatever you're dealing with, and T is temperature. And because, as I told you the last time, I'm a retired Air Force. I was a meteorologist in the Air Force. That's kind of how you model the atmosphere, too. The atmosphere is a gas. So we use that equation as one of what you call the 7 primitive equations that we use to model the atmosphere, which is what you see on TV when you watch the TV weather forecast. But so this is a big part of it. So what we do in this part here is you learn, well, how would I solve this equation for any one of those variables? How would I solve for P or T or N? Now we'll get some practice doing it. You'll see. Actually, the R is not a variable. The R is a constant, right? It's a gas constant. So that's probably the part you're going to find the hardest. But there are things that we do in this class that you really do have to kind of know how to solve an equation that has more than one variable. I mean, take, for example, 2x plus 3y equals 6. Again, that's a thing you should have already had in Algebra 1. It's a straight line. It's a straight line. You know it's a straight line because x to the first power and y to the first power. That's called standard form. It's probably not the form you remember. You probably remember y equals mx plus b, right? But you can put that into y equals mx plus b form, but you would have to be solving this equation for the y, right? So this is another example of a literal equation. You've got to know how to solve it if you want to put it in that form. Another thing that we'll do, we get into another thing you were supposed to have learned is called systems of equations. Systems of equations is when you have more than one. In Algebra 2, we only do nonlinear systems. You should have done linear systems in Algebra 1. We do nonlinear systems. For example, x squared plus y squared equals 4. That's a circle. And if you want to graph it with a calculator, you got to solve for y first. So again, you're having to solve a literal equation. And if you can do that, then the 1 or 2 problems that we get on nonlinear systems become pretty easy. So we already learned the properties of real numbers. There's actually a bunch of properties that allow us to solve equations. At this step, most of the equations we get are linear. They only have x and y to the first power. And you can solve them by isolating the variable on one side of the equal sign, and the answer will be on the other side. Okay. And how do you isolate? You use properties of equality. Here's a basic one, right? It comes from example 1. X plus 4 equals negative 12. What would you do to solve that? You would take 4 away from both sides. So that, and we would say x equals negative 16. Okay, that's called the subtraction property of equality because you subtracted the same thing from both sides. I mean, it's so simple. It's like, does we really need a name for that? But yeah, there's a name for that. That's subtraction property of equality. And the way the book treats this, our book, Algebra 1 book, we start out by doing one-step problems where you only have to do one thing to solve, right? So we did the one thing, X is negative 16. Okay. Okay. Good, Cody? You good? Anybody else? Let me know if I need to slow down. Denise, okay? Right. So here's the four properties of equality. Right. We already looked at this one. That's what we did on that first page. I mean, this is being done with letters to mean this works generally. It doesn't just work when you have to subtract 4 from both sides. It would work if you have to subtract anything from both sides, as long as it's the same thing. Right. So if A is B, then A minus C equals B minus C. You could take the same thing away from both sides. So that's subtraction property of equality. Right. What do you think we call the first one, where we're adding the same thing to both sides? Addition property of equality. Okay. In this one, we're multiplying both sides times C. Which property do you think that is? Multiplication property of equality. And then the last one, division property of equality. All four of those are just kind of common sense, kind of. That's what you're doing to both sides, then we'll call that a property of equality. I like to think of it more generally than that, and that is like this. If you just want to summarize these properties of equality, whatever you do to one side, you do to the other side, right? That includes add, subtract, multiply, and divide, like we just saw. It would also include, which we will do later on in this class, squaring both sides, or taking the square root of both sides, or flipping both sides, right? Take them both and flip them. All of those things. As long as you're doing it to both sides, then you're not changing the balance in the equation. I think I'm going to get there is a tool here that I could put a little clock that's got a second thing going on it. So if somebody like was watching the video, it's like nothing's changing, you would know that, yeah, it's going forward. I mean, you could watch for the minute thing to tick, but in a minute, you wouldn't see anything. Are we done here? Okay. Now, there are some other properties of equality, and sometimes these come up. The first one, I don't think the first one is one you would ever see, but it seems silly in a way. But when you do kind of higher mathematical proofs, you may actually get to a point where you've got to like establish that, I can say that a number equals itself. It seems kind of silly, but that actually has a property name. It's called reflexive. A number equals itself. The next one is called the symmetric property. If A equals B, B equals A. Which, when you were solving equations, if the variable terms are on the right side and you like to have the variable terms on the left, it means that you could switch it. You could make everything on the left, switch the sides of the expression so that you're solving for the variable on the left. I mean, I personally kind of like that better than solving for the variable on the right. The next one is called transitive. If A equals B and B equals C, then A must equal C, right? Because A and C both equal the same thing. A equals C. And then the last one is called substitution. Substitution property we've already done it today, right? When we did this thing here, remember I did this when we were doing the homework. We said 5 minus 1 times A equals 4A. When we substituted 5 minus 1 equals 4, that was substitution property. Because 5 minus 1 equals 4, we were able to replace it. Okay, now we're going to go into actually solving the equations, and we won't even hardly refer to these things, but they are part of the properties that we're supposed to kind of understand why it is we're allowed to do the things that we do to isolate a variable. Are we good? Good. So, for example, there's another one-step equation. We have to solve, which means isolate the variable b on one side. What is with b, and how is it operating on b? 12, and it's multiplying. So how would you get rid of a 12, which is multiplying times b? You do the opposite, right? So the opposite of a multiply is a divide. Divide both sides by 12. Division property of equality. Right? B equals 18 over 12. Which, is there any common factor between 18 and 12? Come on. It's the greatest common factor between those two. 6, right? 6 goes into 18 3 times, and it goes into 12 2 times. So basic canceling, simplifying a fraction would tell us that we can cancel the 6's because they're common factors in the numerator and denominator. 3 halves. Pretty basic. Okay, now if you have more than one step to take, then they call that a multi-step. And these are some procedures for a multi-step. And we'll do some examples of it. So, if you have these next to you while we're doing the example, you'll see how this applies or not, right? You simplify the expressions on both sides of the equal sign. What do you mean by simplify? What did it mean in the homework last night? Simplify meant? What did we do to simplify expressions in the homework class? Combine like terms. So basically, combine like terms on each side of the equal sign. Before you start moving things side to side, make sure you've done everything you can to simplify the left side and the right side. Okay. Right. Then you want to make sure you have all the variable terms on one side. And usually, not always, but usually we move the smaller of the two. Now, if there's any number terms, meaning doesn't have a variable in it, that's called a constant term, then you try to get those on the opposite side. And what you're left with should be a one-step problem. You should be able to finish it off in one step, a multiply or a divide. Good? We're all good? Janine? Okay. So here's one. It's actually taken from the even number problems in the homework. You're going to get the odds to do. The first step would say, simplify both sides. Combine like terms. Is there anything to combine on either side of the equal sign? No, that step's not necessary in this case. Okay, second step would say move the variable terms so that they're all on one side. And normally that means move the smaller one to the side where the bigger one is. Which one is the smaller, 7W or 3W? 3W. So you want to move the 3W. You need to cancel it on the right. What could I do to cancel it on the right? Subtract 3W, right? So because 3W is the smaller, minus 3W, minus 3W. Okay, 7W minus 3W is 4W. Okay, we still have the plus 2, and we've got a 94 on this side. Okay, now we need to get the constants on the other side, right? Not with the side with the variable. Subtract 2. So 4W equals 92. Okay, at that point, it's a one-step problem. What are you going to do to solve it? Divide by 4. So W equals 23. Yeah, you could find, like in the book, when they show their examples, that they don't write it like I do here. That they might be subtracting 3W at the end of the row and subtracting at the end of the row. You know, you do whatever you want, but I tend to write it like straight up and down. Okay, good to go? Next. Okay, how about this one? Any simplifying to do before we start adding things side to side? Yeah, what is it? Let's do a distributive property on the right before we decide what we're going to do. So distribute. Negative 27 plus 6y equals 3y. What's the next term? Minus 9. Right? That goes like that and like that. Okay, now let's get all the variable terms on the same side. Which is the smaller of the two? 3y. So subtract 3y, subtract 3y. Negative 27 plus 3y equals negative 9. Okay, what then? Yeah. Okay, this is a negative 27. In order to cancel it, you got to add 27. 3y equals 18. Okay, last step. Divide both sides by 3. Good. Pretty basic stuff so far. Okay. Okay. Okay, try to solve that one. Oh, sorry. You probably need to be looking at that for a second. Who's got an answer? Who's got an answer? Raise your hand if you got an answer. I'll come around and check it. Jaden? Let's see. Yes. Come on, Sam. Are you doing it?
Oh, yeah.
Write down. You got it right. You should be working it out. Right? Get it through your head. Showing work is not punishment. It's how you get problems right. What you got? Exactly right. What'd you say? No. Let's see. You subtract it. That would have actually given you negative 4D. Negative 3 minus 1D would have been negative 4D. Okay. Who else? Anybody else get an answer?
Yes.
Let's see. I don't think so. You added 3D, gives you 4D. You subtract that, you get 43 minus 9 is 34. Right. That's correct. Get it? That's correct. Correct. Did you get it there? You're right. You're on the right track. What was the answer? 17 halves or 8.5. Right? What was the first? Which is the smaller? Negative 3D or positive 1D? The negative 3D is less than positive 1. Even though the 3 is bigger than 1, the 3 is negative. So it's negative 3 would be to the left of 1 on the number line, therefore it's less. So what do I do to move the 3D? Add 3D. Add 3D. So now I got 43 equals 4D plus 9. Okay, we've got to get all the constants on the other side, so I subtract 9, subtract 9. Now I've got 34 equals 4D. Okay, what if I switched that and said 4D equals 34? What property would that have been? Commutative. Remember, what was the property that said you could switch the sides and it doesn't matter? Symmetric? Symmetric property. So then divide by 4, D equals 17 over 2, simplified fraction. If you didn't simplify the fraction and you turn it into a decimal, you got the 8.5 anyways. In this class, that's fine, okay? Don't worry about it. Okay, try that one. You running into any trouble?
No.
What'd you get? You got to the right spot. We'll talk about what that means. What did you do?
Oh, my bad. I still had it wrong.
Where does 15x come from?
Oh, no.
Right? You can't add the 12 plus 3x, right? Those are not like terms. This is one that does not have an answer. So if you're getting stuck, okay, it's kind of to be expected. This happens. It'll happen to us sometimes during the course where you're solving a problem and you have a similar result. So let's see what happens. If I follow my steps, I would first try to simplify both sides. 7x minus 4x is 3x plus 6. 3x, and then 12 minus 8 is 4. Okay, then I try to get the variables on one side, but they're both the same size, right? They're both 3x. So in the step where I subtract 3x from both sides, I actually cancel all the variables, right? Cancel, 6 equals 4. So I am left with a statement that does not depend on the value of x, and it happens to be false. 6 does not equal 4. That means no solution. There's no way there's no number you could find that you could plug in here to make that statement true. And that's what it looks like when that happens. You lose all the variables, and you're left with a false statement. So that means no solution. Okay. Now, I say you try, but I'm going to just do this one and show you what a similar result would be. Okay, what should I do on this one? Looks like I got to distribute twice, right? 2x plus 3x minus 12 equals 4x minus 12 plus x. Okay, then what? Combine like terms on both sides, right? So now I'm going to have 5x minus 12 equals 5x minus 12. And again, I get to that same step. I'm going to subtract 5x, but it's going to cancel all the x's in one step. So negative 12 equals negative 12. So again, we get a result that does not depend on the value of x. And it happens to be a true statement. And that tells you that this is always true. Right? The solution, you would say, is all real numbers. Anything you plug in will work. And when you get something like that, which is actually true for all real numbers, that is called an identity. Like I said, we will come up, there will be a few times during this class where that will be what we get when we try to solve. And it'll be a statement, it's true, but it doesn't have a variable in it, so that means the original equation was always true. Okay. Good. Okay, this is the previously mentioned literal equations. And literal equation has more than one variable. You have to be told what you're supposed to solve for. So you're going to do 4 of these, and I'm doing 4 here that are like right next to them. So hopefully if you kind of look at the pattern. This one we're trying to solve for G. Well, where is the G? It's on the right. Is it isolated? Obviously not, because then that's why we have to solve it. So in order to solve it, we're going to go through the same set of steps that we would have had this only had one variable in it. That's what we would do. So let's see. What is with the G that we need to move? Just half. How is the 1/2 operating on the G? What's going on in between those two? Some multiplication, right? What's going on in between the G and the T squared? What operation is going on in between those two? It's another multiplication, right? When you write the letters right next to each other, that's a multiplication. Well, in order to get rid of those, we have to do the opposite of multiplication, which is divide, right? So let me take this in 2 steps. I'm going to divide both sides by T squared. All right, now I've got, and I'm going to switch sides, 1/2 G equals S over T squared. I use symmetric property again, just to flip sides. Okay, now the G is still not isolated. As I said, how would I get rid of the 1/2, which is multiplying times G? You have 2 options, actually. You could divide by 1/2. If you divide by 1/2 on both sides, then you get G equals, and then you have to remember that when you divide by a fraction, that's like multiplying by the flip. So that is the same thing as S over T squared times 2 over 1. You turn a divide by a fraction into multiply by the reciprocal, which is 2s over t squared. Now, usually, if you have a coefficient on the variable, which is a fraction, an equivalent thing to do is just multiply by the reciprocal. Right? At this step right here, multiply both sides by 2 over 1. Right? When I multiply this term by 2 over 1, what's 2 over 1 times 1 over 2? It's 1, right? That's like the inverse property of multiplication. So then you get just the g. And then on the right side, you get 2 times that, which is 2s over t squared. So it's okay if you want to think of it like divide, because it's a multiply, definitely dividing by that thing is a proper thing to do. If it's a fraction, probably preferred is multiply by the reciprocal. You will have to do that to simplify it anyway.
Good morning, warriors. Pardon the interruption. Teachers, if you have not done so, please take attendance at this time. It's important for our record keeping and our school roster that we have accurate attendance this morning. So if you haven't done so already, please take attendance at this time.
They can wait. So how about this one? Solve for r. What would I have to get rid of that's with divide by the p and t? Now, if it's really to see what we're doing here, what if we just said, I'm going to make this look like something similar. I'm going to make this 4 equals 3r times 2, right? I just put numbers in those places, right? Now, how would I get rid of this 3 and this 2? Because they're multiplying times r. I would divide by 3, I would divide by 2. So divide by 3, divide by 2, right? If you have a hard time looking at the letters, just substitute some numbers for them, and if that helps you to do that. So over here, we're going to divide by p, and we're going to divide by t. Divide by p, divide by t. Right? Cancel, 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 cancel. I equals good. Right. The first two problems will be like the ones I just did, which are actually considered to be formulas. This is just an equation, and they are all solved for x. It says that in the directions. It doesn't say what to solve for because it says in the directions solve for x. Solve for x. What are the two things that are with x that you need to move? The a and the -5. Right? Which one would you choose to do first? You should always do the other term first. Right? I mean, it's okay if you choose to get rid of the a. What would you have to do? You would have to multiply. So this is what usually happens, right? Let's say I chose to multiply. Then I would have a times x over a. And on the right side, I would definitely have a times b. But we tend to make mistakes. We choose to multiply by the a, but if you multiply by the a on the left, you got to multiply everything by the a. And we tend to not do that. So I have to make sure that's -5a. All three have to be multiplied by that a. So cancel, and now we've got x minus 5a equals ab. Okay, and then what do I do? Add 5a, right? So this x has a minus 5a with it. Right? If you did it the other way, you would add 5 here. And now I've got x over a equals b plus 5. And then multiply by a, right? So a times all of that, x equals AB plus 5A. Same thing. Let's see. I think we got everybody here, so my attendance should be good. So we good? One more. Solve for x. What do you think would be a good first step here? You could distribute. It'd be like on the last one, you know, there was like 2 ways to do it. In this one, there's like 2 ways to do it. That would not be my preference to distribute, but it's not wrong. I mean, if I distribute, it'll look like this. 2/5 x plus 2/5 equals g. Now, you would have to subtract the 2/5 and then multiply by 5/2. What you could do, what was probably preferred, is since that 2/5 is multiplying the whole left side, how about we multiply by 5/2 as a first step? Right? When I multiply this term by 5/2, what happens 5/2 times 2/5? When you multiply a number by its reciprocal, that's the inverse property of multiplication, you get 1. So actually these cancel, and you're just left with x plus 1. And on the right, you've got the 5/2 times g. Come on. Five halves times g. Okay, then you still have one more step, which is minus 1. Now, how are you going to simplify 5/2 g minus 1? Can you combine them? No, they're not like terms. One of them has a g, one of them doesn't. You're just going to have to write them in a row. 5/2 g minus 1. Done. I think that's easier than having to subtract 2/5 and then multiply everything by 5/2. So if you see a fraction in front, just multiply by the reciprocal right away. Probably a little easier. That's what we did. That's the homework.